Hello everyone, greetings of the hour. I am Milan Vishnoi and I am going to demonstrate and I am going to explain the working of my final year project. The name of our project is Smart Lab with Automated Access. Here are the group members' name, me Milan Vishnoi, Kshitiz Saxena, Mohammad Anas and Sachin Singh. We are guided by Miss Navita Agrawal ma'am and our group number is P15. So the requirement are as follows. The platform we have used is Raspberry Pi, language is Python 3, and these are hardware requirements, and these are the software requirements that we have used for making a project. So let me tell you briefly about our project. So in our project we have modeled a lab which allows the entry of a person on the basis of facial authentication. That is, after the facial authentication is done, only then the person can enter the lab and only then he or she can access the node. So and also the node and the nearby equipments, electrical appliances that are like fan and light will be provided power automatically when the node will be assigned to a person, and when the node will be deassigned after the exit of that person, the power that was provided to the fan and light and the node will be turned off. So in this way our lab is automated and smart. We have used our project basically uses two emerging technologies. It is based on two emerging technologies, that is IoT and cloud computing. So the question may arise why we have used cloud. So it is basically because of three reasons. First is limited processing power of RPi. We have to do some kind of image processing. So and RPi's processing power is not enough for that. So we have to use the cloud. And flexibility of storage. We can extend. We have used cloud for the purpose of storing the database of the images. So the benefit that we have with cloud is that we can extend easily the storage, which would not be the case if we had created the database and stored the database on the SD card of Raspberry Pi, because it is fixed, and for extension we have to do a lot of work. But in cloud it is easy to extend the storage. And scalability means if we have to implement the same system for more than one lab, that is for example say 5 labs, so if we had created it on Raspberry Pis, then we had to create the separate databases for each lab. But now as we have used cloud for storage of database, then there can be single database of a particular academic institution, and there is no need to create separate databases on each Raspberry Pi. So these were the three main reasons of using the cloud. First one is the main constraint because of which we have to use the cloud. Now let me tell you some brief about the modules. Our project consists of 4 modules basically. First is setting up the Raspberry Pi. Raspberry Pi is a main component in our project. It does many things. So first step is to set up the Raspberry Pi. We have installed Raspbian OS in it, and then we have enabled BNC viewer so that we can work with it with the help of our laptop. So let me show you how it actually appears after setting up the Raspberry Pi and how we can access it through VNC viewer. So this is our VNC viewer. Using this we will access our Pi interface, and we can remotely connect to it using this BNC viewer. It is available for mobile also, so we can access the interface of Raspberry Pi on mobile also. So here as you can see I have entered the password, and now we have the interface of RPi. It is the terminal, it is the file manager and browser, and we have here application menu. So this is the step of setting up the Raspberry Pi. So now after seeing the setting up of Raspberry Pi, our module second is turning on and turning off the electrical appliances using Raspberry Pi. We do it by using a library rpi.gpio. So this is a hardware based module. A third module is creating the user database, that is registering the user. So obviously if someone wants to get authorized, first he have to go to admin to get himself registered. So this is our third module, and we have used OpenCV for the purpose of capturing the image with the help of USB camera, and the database will be created on S3, and then after the images will be uploaded, we will have to index the faces That is, we have to extract the features of the faces. And how it extracts the feature of the faces? It actually extracts the feature of the faces into the face vector using deep learning neural network algorithms. And this is the main advantage, one more advantage of using cloud, that we can leverage the expertise of AWS scientists also in doing so. So this is what we do by indexing the faces. We extract the face features in the face vector. This is our module. This is our module 3, and a module 4 is authenticating the user, that is entry and exit of the user. And in this we use OpenCV to capture the image of the person, and Amazon recognition for the purpose of comparing whether the person that is a captured image is of the person that is authenticated or not. And we use PyTTSX3 for the purpose of converting text to speech, so that announcement can be made with the help of the speaker, and so that user can be informed about the assigned node with the help of the speaker. So now let me explain you the working of it. There are basically 3 processes with the help of which I can explain the working. First is user registration, second is user entry, and third is user exit. So let me first explain to you the flowchart of them. The flowchart of user registration is as follows. The person goes to the admin, and admin enters the name and ID number of the user, and then the camera captures the image of the person and it gets uploaded to S3. And after getting uploaded to X3, the images are then indexed and the faces in them are indexed, and the the features of the faces are extracted into the face vector. So this was the flowchart of user registration. Now let's see the flowchart for entry. If someone wants to enter the lab, what he has to do is he first has to press the button that is present outside the lab, then the camera will be activated. And if first of all, if the button is pressed, it will be checked whether the lab is full or not. If lab is full, then we have to tell the person to wait. If the lab is not full, then start the camera, image is captured, and then with the help of Raspberry Pi we actually establish connection with Amazon recognition, and we compare it with the existing faces. And if the image is found to be of the authorized person, then assign a node and inform the person about the node number with the help of the speaker announcement, and provide the power to the assigned node and its nearby fan and light. If no match is found, then inform the person that he is not authorized to enter. Now the flowchart for exit. Now our person that we have imagined to enter the lab has successfully accessed the lab, accessed the node, and now has completed his work. Now he wants to go out. So what he has to do, he will have to press the button of the exit inside the lab, and the door will open for him. And if the exit button is pressed, then first he will have to again get himself recognized. He will have to stand in front of the camera so that the node can be de-assigned from him. When he will stand in front of the camera, then his name, we can recognize the person, and the node that was assigned to that person, to the person of that name, can be de-assigned, and the node and the nearby equipments that are earlier provided power will now be turned off. So this was the flow chart. Now let me show you some of the demonstration with the available equipments of our project. So now let's see the working of it. So let's start with the user registration process. So here I have created a bucket on AWS S3 with the help of create bucket with the name of faces MIT. And here as you can see, there are some folders with the name Kshitiz with his student number, Mohammad Anas with his student number, and Sachin with his student number. We can create the folder by clicking on just create folder and by giving up the name. And we can also upload the image manually, but that would be a very tedious task, and that would not be the use of the actual coding if we have to manually upload it. So what we did is we will upload it with the help of Raspberry Pi, with the help of our code. So what will the user do is, if someone has to get registered, if someone want to get registered for entering into the lab, first he or she has to have to go to the admin for his for creation of his database, so that admin can upload the images to S3 and index the faces, so that he or she, when next time will try to approach the lab, may access the lab and his face may be verified. So let's see the code of it. This is the code. Boto3 library is used for accessing AWS cloud, and we have used OpenCV for purpose of taking the pictures with the help of USB camera. And here we have to insert the name of the person and ID number that we will see when I will run this code. And here we are stabilizing the connection with Amazon S3, and here we are uploading 60 images, around 60 images of that person. We can increase the number to increase the efficiency, but here for the purpose of demonstration I have taken a number 60. We can take a bigger number for increasing our results and efficiency. So after it will be added, the program will show that the user is added successfully. So now let's see how this code runs. The name of this code is add faces. So let's run this code. So we have to enter the command Python 3 and the name of that code. Now it asks the name of the person, so I will enter my name, that is Milan. ID number, I will enter my student number 1610260, and now it starts capturing the image. So now as you can see, Milan added successfully to database and successfully added Milan. This means that my photos are added successfully. So let's see whether what has happened. So now let's refresh our whether we see a new folder or not. Yeah, as you can see, we see a new folder named Milan_1610260, which we have created. And now let's see whether there are images. Yes, we can see there are images. There are around 60 images. And now if let's open any one random. So our project group number is 15, so let's open the 15th image. We can open by this, and it is downloaded. So let's open this. As you can see, here is my image that has been captured. And one more thing I wanted to show to you is that it is also saying the date at which it was added, that is 9th May 2020 12:14 AM, and this is when I am recording it, 12:15 or 12:14. And now what next step we have to do is, after adding the faces, any new face, what we need to do is we need to index the faces, so that all the faces that have been added should be converted and should get converted to the string. So now let's index the faces. It is indexing, as we can see. It is indexing. So as you can see, indexing successful, which means all of the faces that we have added have been converted to string, and now they are ready to be compared for verification. Okay, so now let's understand how the entry and exit of the user will be done. So the program that will be up and running in the Raspberry Pi would be main.py, and what is in this main.py, let's see. So main.py consists of nothing but actually two other programs that I have made. One is for entry and one is for exit program, and they are being imported, and these status is the initial status of the lab occupied nodes. So for now we have taken 6 nodes are there in the lab, in our model of lab. So as there are 6 nodes, so there will be 6 names. There can be 6 names. So initially they all are unassigned. So what we have done here is we have taken the input. Here I will be showing you the demo. I will be entering it with the help of the keyboard, but in our model what we will do is we will use rpi.gpios. rpi.gpio is a library, so we will use gpio.input to take the input from the switch. So whenever the input will be pressed, we will compare it accordingly and we will run the programs accordingly. So when for now what we will do is we will type entry and assume that we have pressed the button for entry, and we will type exit and assume that we have pressed the button for exit. So now let's understand what is in this entry program.run and exit program.run. So let's understand entry.py. CV2 is used for capturing, time is used for delay, Goto3 is used for establishing connection with AWS cloud, date time is used for the purpose of saving the name of the accessor with the time, and node and turn are the programs that I have made. Node is for assigning the node, deassigning the node, and checking whether the node are available or not. Turn is for the purpose of turning on and turning off the appliances. So what it does is, first when the run function is called, it checks whether there are any node that is vacant or not. If no node is vacant, then it will show that lab is full and it will ask the user to wait. Now otherwise what it does is it establishes the connection with recognition and S3, and then it captures the image. After that it saves the image in accessor images folder and it uploads the image to S3, and then with the help of recognition what it does is it compares it with the already existing images. And if here is the parameters of the function, S3 object bucket name is faces MIT, as I have shown in user registration part, and the name that we have given is this to the file that will be stored in AWS for comparison purpose, and the database that has been stored earlier would be with the name of the person and ID number of the person. So face match threshold is actually the threshold which we want, how much similarity must be there in the between the saved faces and this captured image face. So I have set it 95% for higher efficiency, and now what it does is it actually match responses, it returns with the name match responses, and face matches is actually a dictionary, and it is a dictionary, but it also consists of another dictionary and then another dictionary and then another dictionary. So there are many netted dictionaries. So we will take the name with the help of external image ID and similarity also, and with that what will happen is the name of the folder will be returned, and the first name of the person will be shown, or we will extract the first name of the person, and then with the help of this we can easily make announcement, and we will assign the node using this function, and then we will turn on the node and the nearby appliances, and with this we will make the entry log in the file. And here is if it does not matches, and exit program is kind of similar, all the things are similar other than this node deassign function and turn off, and we will also be making the exit log record in the records.txt file. So now let's see the running of this program. So it is USB camera and it is connected to this Raspberry Pi, and these are the two equipment that I currently have, and with the help of them I will demonstrate user entry and exit. Okay, so let's run the code. Let's see the output of the code, user entry and exit. So this is the code that would be up and running, main.py, and currently there is no one who is trying to access the lab. So first let's check some things. uh, record.txt. This is a file that is empty right now, as you can see. Let's also see the time, 8 and 8 9. It's 8 9. So let's run the code. As I have said that in place of the button at the entry, I will simply type, for the purpose of demonstration here, entry, so that we can see what will happen inside the Raspberry Pi, what the processing will happen inside the Raspberry Pi when a person will enter the button, when the person will press the button. So I have entered. Face is captured successfully and the person is Milan. Milan is assigned node 1 and nearby light and fan are provided power. So we can see here by going into this folder, project files. Here is, we have records.txt, and yes, Milan is assigned node 1 at 8 9 30 point, and it is also showing in milliseconds. So it is the entry time at which Milan has entered the lab. One more thing which we can see is accessor's image. This accessor's image at time 8 9. This is the image that has been captured for the purpose of that has been captured and being sent for the purpose of verification. So this is the image and this is the entry part. Now what will happen is Milan will be announced that he is assigned node 1 with the help of aux speaker, because we have aux pin in our Raspberry Pi. Currently I do not have aux speaker, so I will not be able to show that demonstration, but yeah, we can assume it. And node 1 and nearby light and fan will be provided power. So now let's see the same thing, and the program is still running because it will be running, the lab will be running. So if suppose Milan completed his work and Milan wants to go out now, so what will Milan do is Milan will press the button inside the lab. That would be the button of exit. So the same thing will happen after I will click exit. That will happen after pressing the button. So let's see, Milan again have to go through a facial verification process so that the node can be deassigned from him. Person detected is Milan, and Milan exited, and node 1 is deassigned, and node 1 and nearby light and fan are turned off. So let's see in our again project file, record.txt. As you can see, this Milan exited lab at, this is the date 11th May 2020, 8 o'clock and 11 minutes 39 seconds. So this is the time around which Milan exited the lab. And one more thing will happen is we will get the image in this folder, exiter folder. You can see 11th May 2020. This is the time, and we have named this with the help of using library datetime, and there is a function in datetime.now. So you can see this is the exiter image, and this is me same in the same pose because I have exited after 3 minutes, so it is the same pose. So this is about entry and exit. Node 1 and nearby lights and fans will be turned off. So this is how our project will work, and I hope you must be able to visualize it with the help of these things that have been written. In place of this Milan is assigned node 1, there will be a speaking announcement, and this will be a practical step. Node 1 and nearby lights and fan are provided power, that we had demonstrated in our module 2 of controlling hardware with the help of Raspberry Pi. We will use library rpi.gbio for this purpose. So this was the working of entry and exit. So one more thing that can be demonstrated is how we are going to announce and inform the user about the assigned node and about other thing. So we will use the text to speech feature with the help of P15. It is a Python library. Currently I do not have the aux speaker, so I cannot show it with Raspberry Pi, but yeah, I have the speaker in my laptop, so I can run the code on laptop, and just for the purpose of demonstration I can show how it will be like that. Because the same code will be can be pasted and it can run in the Raspberry Pi as well, because this is also Python 3, and in Raspberry Pi also we have used Python 3. So for the purpose of demonstration of text to speech in our project, let me run this code. Let me show you to run this code and how it will appear or how it will sound.
Your face is getting captured, please look into the camera. Your face is captured, please wait while we recognize you. Milan recognized. Milan go to node N. Milan exited.
So these are the few lines that we will hear in our project. So this is why I demonstrated these lines. So this was about the text to speech feature.